29, it says 30% of those in attendance. What did the word of mean? Times. And what's 30% actually worth? So, 0.3 or 0.30 of those in attendance, so times those in attendance. Yeah.
Didn't we change that to 11 through 15 and 20 through 22, so like 11 through 52?
Yeah, we skipped the triangles part. 30% of those in attendance had never seen a lacrosse match before. How many of the 400 in attendance were watching their first game of lacrosse? So, if there was 400, 30% had never seen it, so 30% would be their first time. And it says there's 400 people there. So, where should I put the 400? Those in attendance. So 30% of those in attendance, it would have been their first time to see the lacrosse match. So that would be it.
120.
I think there's a follow-up question though. How many had previously seen a game of lacrosse? So if 120 people had never seen a game, how many of those had seen the game before?
36.
400 minus 120.
380.
280. So 120 had never seen it, 200 comma 280 had seen it before. Or you could have figured out what 70% of 400 was. That would also work. All right, now we get into the challenging part. The Zimmermans know that they usually average 55 miles an hour when driving 750 miles. What kind of problem is this probably going to be? What kind of problems are like this? Distance equals rate times time. And usually we start with the arrows, you guys recall? So 55 miles an hour would be the what? The rate. 715 miles would be the distance. And it says they leave at 6 a.m. Does that mean 6 is their time? No. Time is how many hours have passed. So 6 just tells you the starting time, not how many hours they traveled. Okay, on 30 it says, what time should the Zimmermans tell their grandparents to expect them to arrive? I don't know if this makes a good arrow problem. There's not really two different distances on this one, there's just one. So distance equals rate times time. They're supposed to travel 715 miles. Their rate is 55 miles an hour, and we're asking how long would they have to, how many hours would they have to drive? So how would we solve that for t? Divide. What's that come out as?
13.
So 13 would be 13 hours. So what time should their grandparents expect them? If they left at 6 a.m., what time of day is 6 a.m.? Okay, if they left at 6 a.m. and they're traveling for 13 hours, AJ, what time should they expect to get there?
7 p.m.
Right. 6 a.m. plus 12 hours is 6 p.m. Do you guys know that?
Yeah.
It takes 12 hours to get around the clock. That would be, so if you go 1 hour longer than that, then that would be 7 p.m., 7 in the evening. That would be okay, 31. If they arrived at 9 p.m., what was their average speed for the trip? So, if they started at 6 a.m. and they arrive at 9 p.m., how many hours must they have been traveling?
15.
Right. 6 a.m. to 6 p.m. is 12 hours. And then 6 p.m. to 9 p.m., that would be another 3 hours. So yeah, altogether, they must have been traveling 15 hours. So in this case, the rate must not have been 55. Their time was 15 hours. And we don't know their rate, so how would we find the rate?
You do 750
Divide by 15. And the rate stands for speed, so that would be like miles per hour. That would be how you would label that. 47.
47.6 would be.
Okay, they put 47.7 miles per hour.
What do they put for miles per hour? 47.50?
47.7. They rounded off. 32. On the way home. So on the way home, they're still going the 750 miles, so the distance has not changed. The Zimmermans left at 10 a.m., 10 in the morning, and drove an average of 50 miles an hour before stopping at a hotel for the night at 6 p.m. How many miles do they need to travel on the next day to get home? Okay, so if we can figure out how many miles they traveled on the first day, then we can figure out how many miles they have left. So if they started at 10 a.m., yeah, and they went to, what did it say, 6 p.m.? Okay, how far is it from 10 in the morning until noon? 2 hours. They started 2 hours before noon. So to get to 12, at noon it is when it flips to PM. Or at midnight is, we call midnight 12 a.m. But anyway, noon is 12 p.m. It took them 2 hours to do that. And then how long is it from noon to 6 o'clock? It's 6 hours. Okay, on the clock, think about it, from 12 to 1 o'clock, that's 1 hour, right? So to get each hour's another number on the clock. So anyway, that would be another 6 hours. So they must have been driving for 8 hours. Okay, 2 hours gets them to noon, 6 hours gets them to 6 o'clock. So 8 hours in total. So their time is 8 hours. Their rate, I guess I'll put that over here. They told us was 50, their average rate. So that means you stop a couple times, that slows you down. You drive through town, that slows you down. That'll tell us how far they drove the first day. Distance equals rate times time. So how far did they get the first day? 400 miles. But the question was, how far do they have left to drive the next day? Yeah, the total distance to the grandma's house or whatever is 750. So you just subtract those two and you get 315. Those were a little bit different than the ones we did on the worksheet, because the ones we did on the worksheet, probably the one I'll put on the test, is two separate distances, like with the arrows driving away from each other, or like the same distance twice. Okay, so it's less likely to be like that one, just distance equals rate times time. All right. How far did I say we're going? 39? Wait, I said 32, 36 to 39. Yeah, okay, I see why I didn't want to do those. All right, yeah, that's fine. 36. I think I'm going to add on 42 and 43 though, because I do want to do a distance problem, a couple distance problems. quite the mess, isn't it? Okay, 36. A merchant, we don't call them merchants, bought a boat for $8,000 and marked it up 15.5%. What is the retail price? In other words, what's the new price? So how do I move $8,000 up 15.5%?
8,000 times 0.155, and then what do you get from that plus 8,000?
Okay, yes, that is correct. You guys hear what I said? He said we could do we could find 15.5% of 8,000 by multiplying by 0.155. Then whatever that is, that's how much the price is going up, and so we could add that back to 8,000.
9,240.
Right. So if you multiply and you get 1,240, does it make sense that the price would go up to 1,240? No. The price is going up by 1,240. Okay, so after you multiply, you can add it back to it. There is another way we learned to do it last week. Do you guys remember the other way? If you're marking, it's always during this class. 100% of 8,000 is 8,000. If you're marking it up 15.5%, that's like you're increasing it to 115.5%. So that would be like multiplying by 1.155 to this. That would do it also. You could do it in one step that way. But yeah, multiplying it by 0.155, that gives you the markup. And then to mark it up, you actually add it.
And then it says 5% sales.
Oh, does it? Okay, so in other words, we need to, the sales tax is going to add another 5% onto that. So you're going to have to pay a tax on the total, not just the 8,000. So we need, how do I mark this up by 5%?
Multiply by 0.05.
You can multiply by 0.05 and add it again. Or does anybody know the other way? If you're marking something up 5%, then it's going to be 105% of what it was. So you could do it in one step by multiplying by 1.05. That would also work. Maybe we should stick with the two-step solution. That might be less confusing. So what is that times 5%?
9702.
I'm guessing they rounded it to $97. I kind of lost my place. What number are we on? 36.
I'm on 34 and 62.
What will the buyer have to pay if there is a 5% sales tax? What'd you say? It was 90.
9,700.
Wait for it.
Or just the tax. What was the tax?
462.
162. That makes more sense.
462.
4. Okay. There we go. So yeah, they actually asked for both these answers. What would the retail price be after the sales tax? What would it be? Okay, 37. Traveler priced an airplane ticket at $6.50. He was later able to get it for $400. What percent did he save? Okay, I want you guys to try on your own so you can figure out how to do this one.
37.
Yep, on your own. The price went from $6.50 to $400. What percent did he save? How do we find the percents that the prices change? Davin, Wyatt, what did I just say to do? Try the problem. Okay, when a number changes, how do we find what percent the change is? Right here, it's been on the board for quite a while. Percent change is change divided by original. What is the change on number 37?
400.
No.
250.
Yeah, it's going from 650 to 400. The amount that it's changing is 250. You subtract those two. What is original?
650.
650. So you do 250 divided by 650. What's that as a decimal?
0.38.
385.
Because it was like.
Does it tell us to round it somewhere?
What was 0.38461?
Okay, anyways, when we move the decimal twice to change it to a percent, we got 38.5%. Anytime it's asking us for a percent change or they could call it like discount rate or something, that's a percent also. Anytime they're asking for some kind of percent change, they might call it the markup rate. That's a percent change problem. You do change divided by original. Okay, 38. The retail price of a suit was $7.19. That means it was on the shelf for $7.19. It was reduced 33% and later an additional 67%. What was the price after both reductions? What was the total percent? Oh, that's so many questions. They only put the answer to 2 of those questions down. Okay, anyways, we're starting at 719 and we want a 33% discount. In other words, we want to take 33% off. So who can tell me, how do we take 33% off this price? Okay.
You go 719 times 0.33 and then subtract that from 719.
Right. 719 times 33%, and whatever that is, we can take that away from 719.
237.27.
So I'm going to subtract. You guys are going to subtract. All right, what's that come out to?
481.73.
Okay, after that, I guess nobody was buying it because they did another discount. 67% off this time. So how do I drop this by 67%? Yeah, kind of the same process, times 0.67. Now we're doing 67% of the new price, not of the old one.
22.75.
Well, we're talking about money, so where should we probably round it?
So you were so
76.
So that is a big price drop. All right, what do we get? On what?
58.97.
Okay. That is officially a deal. Now, they asked another question though. And the question is, what percent overall, what was the percent of the price drop? It kind of looks like, if you put these together, it looks like 100%. But 100% price drop would actually be $0. Okay, the reason this is not 100% is because we did 33% of this and then 67% of something else. So anyway, how do we find what percent the price effectively dropped? Percent change. Change divided by the original. How much did it change from here to here? You'd have to subtract these two. 719 minus 158.97.
$56.60.03.
Hmm?
560.03.
Yeah. Okay, that's the change. Dropped that much. And then the original was 719. Is that an odd or an even? I kind of lost track. Looks like they rounded it to 1/10%.
So 0.8.
No, that's not what they put. Okay, 0.8 would be a tenths place. That would not be the 1/10%. So 1/10%, because you have to move the decimal twice, would be like the third decimal place.
So
Yeah, 77.9%. The 1/10% is actually the thousandths place, but after you move the decimal, it's the 10th place. All right. 39, we're almost there. We're getting there. Ron got a 15% commission on his sales, plus a $1,500 monthly salary. Determine his monthly salary goal if he budgets $37.50 as his monthly income. Do you guys remember what commission meant?
You get a certain percentage.
You get to keep, if you're a salesperson for like houses or cars, you get to keep a certain percentage of what you sell. It says here Ron gets $1,500 just for being alive. Plus he's gonna get what? Right, 15% of however much he sells. I'll call that S. And he wants to make, in the month, he wants to make,
3,750.
yeah, $37.50, $3,750.
Just multiply all those together.
No. Okay, it's just like a basic algebra problem. You guys see it?
Is that plus or?
Or we could call this an X. He's gonna make $1,500 no matter what, plus he's gonna make 15% of what he sells, and he wants to make $3,750. So how do we figure out how much does he need to sell? How do we figure?
1,500 from 3,750.
Right, just do some algebra. Subtract 1,500. I'll tell you guys tomorrow what the word problems will be like, so you're gonna be totally surprised. I'll probably put a couple on there. So to reach his goal, he has to sell $15,000 worth of whatever he's selling. Okay, couple word problems and we'll call it good. Or a couple of distance problems. 42. Julie drives the 120 miles from Greenup to Newton. Okay, how do we usually start these problems? Or how did we start these on the worksheet? Arrows, yes. So I want you guys to see if you can figure out what the arrows should look like. Are they like the same length? Are they going opposite direction? What are they? Julie drives 120 miles from Greenup to Newton at 46 miles an hour, while Beth drives from Newton to Greenup at 34 miles an hour.
They're the same length but different ways.
Well, no. Let me read the rest of the problem because it kind of, how long will it take for Julie and Beth to meet each other? So are they going to make it all the way to the other town? No. They're just going to meet up somewhere in the middle. So they're heading towards each other, but they're not going to make it to the other town. They're just like meeting somewhere in the middle. Everybody's phone's on. Okay, are they going the same distance? Probably not, no. Unless they went the exact same speed or something. It says Julie drives the 120 miles from Greenup to Newton. Where should the 120 miles go? Somebody needs to silence their phone for next hour, I guess. Okay, they mean the towns Greenup and Newton are 120 miles apart. That's what they mean. So that means like all the way across here is 120 miles. Oh, by the way, how do I label each of these arrows? Rate and a time. Each of their distances gets rate and a time. Julie is going, this will be Julie, from Greenup to Newton. The other girl is Beth. Okay, it says Julie was going 46 miles an hour. So where do I put the 46 miles an hour? That's her rate. Beth's going 34 miles an hour. That's her rate. Let's see. They leave at the same time, so that tells us that their times are the same. So we can just leave them both as T. All right, now, this might be like the one on the test now I think about it. This could be the same type. Yeah.
Would you do like 46 plus 34?
Yeah. Yeah, if you think about it, Julie's distance plus Beth's distance, that would give you the total distance, right? So this plus this equals this. 46t plus 34t equals 120. Add those together. What's 120 divided by 80? Okay, 1.5. And what are we talking about here? T stands for time, more specifically what kind of time? Hours. So it's, yeah, it'll take them an hour and a half before they run into each other. Or drive by each other or whatever. Okay, should I sign 43 for homework? Does that sound like fun?
No.
Okay, yeah, 43. You'll need, since it's an odd, you'll need to show some work to get credit. Jorge jogged the trail to the waterfall at 120 yards per minute, and he walked back at 80 yards a minute. Okay, this is not miles per hour, but that's still a rate, yards per minute. That would be their rate. Anyway, what should the arrows look like? Jorge jogged to the waterfall. He walked back. Okay, yeah, it'll be arrow there, arrow back. What do we know about these two distances?
20 miles.
No, that's the other problem. We know that they're the same. So whatever you put for their rate and times, this one should equal that one. Got it? Whatever you put for this rate and time, that should equal this rate and time. So it's a little different than the other one. It's not this plus this equals the total, it's just this one equals that one. Alright, that'll be your, and if you didn't finish anything yesterday on page 140, give it a shot. I'll walk around if you guys need some